A raindrop falls from rest through air with velocity v and acceleration a. Which graph best represents the variation of a with v? Notice that air resistance is not negligible. It is moving with air resistance. Initially, it is dropped, so it means that v is 0 and only weight acts on it and the second Newton's law. F net is ma, so mg is ma, acceleration is g, it's acceleration due to gravity, 9.8 meters per second squared. And since it has acceleration, speed increases, and a force of air resistance, the opposing force, is proportional to speed. It may be proportional to speed squared, it doesn't matter. So when speed increases, a force of air resistance also increases, and sometime later there will be net force which is less than mg but not 0, so there will be acceleration which is not 0 but less than g, and again, since it has acceleration, speed increases, and the opposing force, the force of air resistance, also increases, and eventually at some moment of time, the force of air resistance becomes equal to mg, and it means that net force is 0 and it is equal to ma, so acceleration becomes equal to 0, and it means that it starts to move with constant speed, which is called a terminal velocity. So again, it has acceleration, speed increases, the opposing force, the force of air resistance, also increases, hence a decreases. Net force, initially net force, it's initially mg, then it decreases, and eventually a becomes 0 and v becomes constant, which is called the terminal velocity. So initially acceleration is not 0, it's g, when v is 0, so it cannot be c, and eventually a becomes 0, and you can see that it's d only, so it's d. And that's all for this question.